This is question number 39 on page 131. The question is, a 3 kilogram block starts from rest at the top of a 30-degree incline and slides its distance of 2.0 meters down the incline in 1.5 seconds. So, as you can see right here, I drew the incline and I drew the little 3 kilogram block and all the forces acting on it. I also set my x and y direction and I drew the x and y components of the weight. So for the first part, we need to find the magnitude of the acceleration of the block. So we know that the block travels a distance of 2 meters in 1.5 seconds, and the block starts from rest, so the initial velocity is 0 meters per second. And I just plug these values into a kinematics equation in order to get that the acceleration is about 1.78 meters per second squared. Okay, so part B asks us to find the coefficient of kinetic friction between the block and the plane, which means we have to find mu. So what I did was I looked at the diagram that I drew, and I found the sum of the forces in the x component and in the y component. So let's look at the y component first. So we see that there's the normal force acting in the positive y direction, and then a component of weight acting in the negative direction. And remember that we set these directions here. So if that's happening, we also know that there's no acceleration in the y component because it's only going to be sliding like on the plane, you know? So because of this, we know that the sum of the forces in the y direction has an acceleration of 0. And so therefore, the normal force equals the component of weight, which is mg cosine 30 degrees. So I also found the sum of forces in the x component, as you can see, and all I did was I plugged in all the values I knew, including the value of the normal force according to the what we solved for in the sum of the forces in the y component. And when I solve that equation, I get that mu is equal to 0.37. Yeah. So part C asks us to find the friction force acting on the block. And if you remember from class, the force of friction is equal to mu, the coefficient of friction, times the normal force. And remember we solved for the normal force earlier in terms of the weight and the angle. So if we plug in those values, then we get that the force of friction is equal to 9.36 newtons. Part D asks us to find the speed of the block after it has slid 2 meters. And again, we just have to use kinematics. So we know that the block travels a distance of 2 meters, that the initial velocity is 0 meters per second because the block starts from rest, and that the acceleration is 1.78 meters per second squared because remember we solved for that earlier. And if we plug that into a kinematics equation, then we get the final velocity of the block after 2 meters is about 2.67 meters per second. Woohoo!